Hello everyone and welcome to the Math Tablet. In this session we're having a look at differentiation, in particular the sign test. The sign test is used to determine the nature of a stationary point. So using the sign test we can tell whether it's going to be a maximum turning point, a minimum turning point, or perhaps a horizontal point of inflection. Let's have a look at this example here. We're asked to use calculus to find the nature of the stationary points in this particular function. Well, to find the nature of this function, we better start off by finding the stationary points first. So my function is f of x equals x cubed minus 3x. I firstly differentiate it, so find f dash of x, so that's 3x squared take 3. Now, key point here, stationary point will always be when f dash of x equals 0. And that's because whether we've got a maximum turning point, a minimum turning point, or perhaps a horizontal point of inflection, at any of those instances, the gradient will be 0 at that point. So we set the gradient function to be 0 at that point. So 0 equals 3x squared take 3, giving me 3 equals 3x squared. X squared is 1. And therefore x must be plus or minus 1. So we've actually got two stationary points there. When x equals negative 1, let's see what will y be, substituting that into f of x. If x equals negative 1, we're going to have f being equal to 2. And also when x equals 1, f of x will be equal to negative 2. So I know that at these 2 points, negative 1, 2, and 1, negative 2, it is going to be a stationary point. But I don't know yet whether it's going to be maximum turning point, a minimum turning point, or horizontal point of inflection. Now that's where the sign test comes in. So with each of these points here, what you would do is to set up a little table like so. Put in your x value in the middle. So let's say we start off with x equals negative 1 here. We already know that f dash at negative 1 is 0. Now we choose an x value on either side of negative 1, and we usually just pick an integer on either side of that middle value. So we've got, say, x equals negative 2, and maybe x equals 0 as our values to check. So let's see, we would substitute x equals negative 2 into our gradient function f dash of x. F dash at negative 2 works out to be 9. Okay. And f dash at 0 works out to be negative 3. Now with the sign test, as the name suggests, you're looking for the sign of these numbers here. So notice the 9, for instance, is positive. So that means it's going to be an increasing gradient. It doesn't matter so much the value is 9. The point here to note is that it is a positive number, giving you an increasing gradient. And also on the other side, when x equals 0, we've got a gradient of negative 3. Again, the value doesn't matter so much. It is the fact that it is a negative value, which means a decreasing gradient. So think increasing, 0, decreasing. That would suggest then negative 1, 2 is a maximum turning point. Okay. Now we're going to do the same for the other stationary point, which had an x coordinate of 1. So again, choose a value on either side. Now it is habit that we just choose the next integer on either side, but you certainly could choose any x value as long as you've got 1 on each side of the chosen value of x. So we already know f dash of x at 1 is going to be 0. When x is 0, f dash at 0 is negative 3, and when x is 2, f dash at 2 is going to be 9. So here we go, decreasing gradient, 0 gradient, and increasing gradient. So this would tell me then that the point 1, negative 2 is a minimum turning point. Okay. Now we can verify this just on our class pad. So we just bring up your class pad. Okay. Now on here we can just graph it, and you can tell that I've actually got the graphing facility set up there. So let's say x cubed minus 3x, that's my function there. If I now just graph it, if I now just graph it, you can see that here at x equals -1, so this is obviously the point -1, 2, it is indeed a maximum turning point, whereas at here at the point 1, -2, it is indeed a minimum turning point. So we've just verified it by checking it on our class guide. I hope you have enjoyed the session of the math.